All right, here we go. This one's similar to the last question, but of course they made it a little more difficult. And I want you to practice this. We've done one in class like this, but it's been a while. So again, you have a function defined as an integral, but you've got another extra little piece to it. So they're making it a little more difficult. So, but a lot of the ideas are the same. So letter A says find f of 7. So f of 7 would be equal to what? Well, I'm going to plug in a 7 every time I see that x. So 3 times 7 plus the integral from 0 to 7 of g of t dt. Okay, so of course I get 21 for that piece. Now the integral from 0 to 7, I just have to break up into, two integrals. This is a semicircle and it's below, so I'm going to put a minus. The radius is 3, so the whole circle would be pi r squared, so 9 pi, but it's only half the circle, so it's 9 pi over 2. And then between 6 to 7, I'm just going to count, 1, 2, 3, plus 3. Again, I'd leave it just like that. Done. Now, f prime of 7 is going to be what? That's what the question's asking. Now, let's look at, okay, that's really what it's asking. So what is f prime of x equal to? Let's look at this statement, and I take the derivative of each piece. So the derivative of 3x is 3, plus, what's the derivative of this part? Well, that's the function defined as an integral. So if I replace, that would just be g of x. So now f prime of 7 is pretty easy. 3 plus g of 7, we have the graph of g, right, is 3, so I get 6. Notice my labeling, everything's neat. I would get 1 point for getting f of 7 correct, and I would get 1 point for getting f prime of 7 correct. But again, you have to show where you got your work. So if you just put f prime is equal to 6, y'all, I assure you, you're not going to get credit, especially this year when, it's online and you have to show where you're getting this stuff. So even though there's only one answer point, this showing that work is super, super important. All right, let's look at part B. Okay, especially if you've watched the video from the last question, you're going to be like, well, you said to do one thing and now you're saying to do something else. Well, it all depends how the question is posed, and I know that makes it so hard. It says, find the x value in the closed interval -4 to 3 at which f attains its maximum value. So if you happen to watch the video from last time, you would say, well, the absolute maximum occurs on f at an endpoint or when f prime changes positive to negative. The trouble is, the reason why this one's different is because you have that extra stuff in there. Yes, if this were the graph of f prime, then I could say, oh, where f prime changes positive, negative, and I'm able to look. The problem is I'm not able to look at this graph and know that. So the absolute, I'm finding the absolute max on f occurs at endpoint or when f prime is equal to 0 or undefined. Again, I can know it's not going to be undefined because I can take that integral anywhere, and so that's not necessarily true. But here's the deal. See, this part's a little more complicated. F prime, remember, this g is not equal to f prime. We said in part A that in order for f prime to be equal to 0, f prime was this. So where is g of x equal to -3? So g of x is equal to -3 at x equals 3. So you're not able to tell that. You can't say when f prime is changing from positive to negative because it's not just looking at the graph. So that's why this one is different. And so you have your candidates. And remember, what's on the right side of this is always what you're trying to maximize.